Welcome to my Switching, Routing, and Wireless Essentials course. This should be the CCNA version 7 curriculum. This is the second of 3 courses. Module 9, FHRP, or First Hop Redundancy Protocols. We're going to be covering First Hop Redundancy Protocols, and we're going to be looking at specifically HSRP. That's one that's heavily used within the Cisco realm. So let's go and jump right on in. What is a first hop redundancy protocol? Well, when we're leaving a LAN, one of the things is we go from one layer 3 boundary to another network. We send that to our default gateway. We already know how routes are created and how data flows in a network. The issue is what happens when our gateway goes down. That's the limitation. If we only have a single gateway, if it goes down, our network communication stops. So what First Hop Redundancy Protocol allows us to do is a process called providing a secondary gateway, or providing a virtual gateway for router redundancy. So the mechanism that provides the alternate gateway in this type of switched network basically is more than just a virtual connection. It does allow us to do virtual gateways per VLANs, and it does allow us to do multiple addresses per interface. So as we were talking about router redundancy, it allows us to set a virtual router so that the default gateway is tied to a virtual router, and we tie that virtual router to 2 interfaces. That way, if one physical interface goes down that's hosting the virtual router, the other interface still is available. And the nice thing with this is we can also provide a virtual MAC address. So the ARP resolution returns the MAC address of the virtual router that again is tied to at least 2 interfaces. So the frames that are sent to the MAC address to leave the network will be that of the virtual default gateway, not that of the physical paths. So the protocol that's used to identify one or more routers as the device that's responsible for processing the frame or address of a single virtual router. Hosts again will send traffic to that virtual device. A redundancy protocol provides that mechanism for determining which device should take the active role and which device should just be waiting just in case. And they need to have the rules for transitioning from an active device to a standby device. And what rule will that standby device become active? The ability of a network to dynamically recover from a failure is known as a first hop redundancy. So let's go look at an example. Here we have 2 actual physical routers. Actually, let me grab my pen. Physical. This is the active, this is the standby. When this connection no longer is available, this no longer is active, this is no longer standby, the standby router will listen. When they can no longer hear the active, they promote themselves to active. That way, the virtual router that's acting as our default gateway will automatically go from the first router to the second router. So the standby router stops seeing the hello messages from the forwarding router, the active router. The standby router will assume the role of a forwarding router. It becomes the new active router. Because of the new forwarding router will assume both the virtual IP and virtual MAC address of the virtual router, the host devices will not see any disruption. It's still forwarding data to the same virtual MAC and the same virtual IP. However, any type of session states that were currently on the original active router, those session states will terminate. So there are some pros and cons. Recovery is active fairly quickly as well. Alright, so what are some of the routing options? HSRP, Cisco proprietary. HSRP for IPv6. We have a Virtual Router Redundancy Protocol v2, also known as VRRP v2. This is a non-proprietary election protocol that's dynamically assigned. VRRP v3, this provides the capability to support IPv4 and IPv6. We have a Gateway Load Balancing, GLBP. This is a Cisco proprietary HFRP that protects data from a failed router, very similar to HSRP and VRRP, while also providing balancing or load sharing. GLBP for IPv6, same thing, but for IPv6. And then we have an ICNP router discovery protocol. This is a legacy for HFRP. So predominantly in the Cisco realm, you learn HSRP. In non-Cisco realm, it could be a combination of VRRP or GLBP. So let's go jump right on in. HSRP. Again, this is Cisco proprietary, and there is one for IPv4 and IPv6. HSRP ensures high network availability by providing first hop routing redundancy for IP networks. HSRP groups are quick to assume packet forwarding responsibilities if the active router fails. The backup will respond back fairly quickly. So there's two major concepts when we're dealing with HSRP, and that's going to be priorities and preemption. So the role of the active and standby router is determined by the HSRP election process, which router is going to become active, which router is going to become standby, and how are we going to manage that. So the role of the election process is by looking at the configuration. So by default, the router with the numerical highest IPv4 address is elected as the active router. However, we can do some priority changes if necessary. The priority can be used to determine the active router. The higher the priority, the likelihood that will become the active router. By default, HSRP priority is set to 100. If the priorities are equal, the highest IPv4 address will be active router. That means to configure your router to be an active router, we can use a standby priority interface command that ranges between 0 and 255. You can always lower the number to guarantee a specific router will be set to standby. Again, default is set to 100. So if we have the default on one router and we have a secondary router set to 90, the default router should become active because it's the highest priority number. The next concept is what's known as standby preemptive. So by default, an active router becomes the active router. Period. It remains active even if another router comes online with a higher priority. The active router is the active router. Period. So what's interesting is we can force new elections by allowing standby preemptive interface commands. Preemptive basically is the ability of an HSRP router to trigger the election process. So if we have active standby, our original router goes down. Our backup router becomes our new active. If the original router comes back online, it doesn't matter the priority. The backup router has already taken the active role. So what we can do is we can set the routers to actually be preemptive, meaning when the original router comes back online, we can trigger it to allow for a new election process. And again, we do that with the preemptive commands. So again, preemption, when that is enabled, every time a new higher priority comes online, they can assume the active router role. Preemption only allows for routers to become the active router if it has a higher priority. Again, it will trigger an election, but the highest priority will always win. Again, with preemption disabled, the router that boots up first becomes the active router. There are 5 main states and timers that need to be followed when we're dealing with HSRP. So the states are the initial, learn, listen, speak, standby. The initial, this state basically is entered through the configuration change or when an interface first becomes available. Learn, the router has not determined the virtual IP address and has not been seen a hello message from the active router. In this state, the router waits to hear from the active router. Listening, this means that the router knows the virtual IP address, but the router is neither the active router nor standby, so it's listening for hello messages from other routers. Speak, this is when the router sends periodic hello messages and actively participates in the election of the active router and or standby router. So again, when the router first comes online, these are the initial processes until we get to the speak. The speak actually figures out the active and backup routers, and then from there, router candidates will either become the next active router, and then it will send periodic hello messages. The election process puts one active and then the other one in standby. So time, what are we talking time-wise? So the active and standby HSRP routers send hello packets to the HSRP group via multicast address every 3 seconds by default, meaning if the active router is not heard by 3 seconds, the standby router is kicking in. The standby router will become active if it doesn't receive a hello message after 10 seconds. So the backup does wait a few failed listens. 10 seconds go by, no hello message, automatically kicks in. You can lower these timers, but they'll lower the timer, more packets having to be processed, so that does involve additional CPU and memory usage, so do keep that in mind. So one of the big things is you never want to set hello timers below a second or hold timer below 4 seconds, just because of the CPU demand it would place on the device. Questions, concerns, please reach out. Thank you.